Hello, everybody, and welcome to the California Small Farm Conference. We are getting serious about soil sampling this afternoon. So if that's what you're here to find, you're in the right place. Thanks so much for being here on day 2 of the conference. We have some wonderful panel discussion and a video diving into what we all love and worship, which is soil. So I encourage folks to use the chat and Q&A feature to ask questions and comment. Otherwise, enjoy the workshop. I'll pass it over to you, Hope. Thanks so much for being here.
Hi, everyone. We're excited you could join us today. My name is Yurtzi Sanchez, and I am the Community Education Specialist with the Small Farms Program. Today's session is broken into 2 sections. The first section is going to be a video on how to soil sample, and the second portion is going to be focused on soil interpretation. And with us today is Hope Zabronsky, Academic Coordinator with UCA&R, Annie Burkholder, Soil Scientist at Della Valley Labs, Margaret Lloyd, Small Farms Advisor, Patricia Lizicki, Vegetable Crops Advisor, and Daniel Geisler, Nutrient Management Specialist at UC Davis. We do have a lot of information to cover today, so we're going to jump right into it. And Hope is going to start us out with a video.
Hi, everyone. Thank you again for joining this session. We will begin by explaining several key concepts and best practices for soil sampling before we move into the field. So what is the purpose of soil sampling? Essentially, the goal is to evaluate, monitor, and also improve the physical, chemical, and biological characteristics of soil, which is known as soil health. And one component of soil health is soil fertility, or the nutrient status of soil, which is highly dependent on the chemical properties of the soil itself. So once you've evaluated soil fertility, you can also improve on-farm nutrient efficiency by understanding the specific nutrient requirements of your crops. So this soil sampling and interpretation session will largely focus on soil fertility. So the tools required for soil sampling include 2 plastic buckets, as you can see here on the left-hand side. One is for collecting your soil samples, and one is for carrying supplies in your field. The second is a labeled soil sampling bag. Here we've just used 1-gallon freezer storage bags that have been labeled with the field, the APN, the GPS coordinates, and the address, and the grower's name, so it's identified in the lab. And then we also recommend bringing a permanent marker and tape into the field to label your samples, although you can do this ahead of time. And then for collecting the samples, we recommend a straight shovel or a soil probe, depending on which method you'll be using, and either is perfectly fine. And then here you can also see the white bucket is a disinfectant spray, and this is really important if you'll be using these same soil sampling supplies for different fields, if you know there might be a pathogen or disease in one of those fields. And then an optional tool is a small trowel, which could help you remove excess vegetation or litter that's on the soil surface before you use the shovel or soil probe to collect your sample. So when should you collect soil samples? We recommend sampling in the spring or the fall when it's not too dry or too wet in the field, and to collect samples the same time every year for the most consistent results. It's also important to sample early enough so that the results are available before any scheduled fertilizations, which could impact your management decisions. And then it's not recommended to sample immediately after applying fertilizer, manure, or compost, or immediately after a heavy rainfall or irrigation event. And then in terms of best practices for soil sampling, it's really up to the producer to determine the size of the area that they would like to monitor. Here are some best practices that we recommend. So the first best practice is uniformity, and really making sure that the sampled area is as uniform and consistent as possible. And we recommend dividing any non-uniform fields into blocks based on cropping history or crop varieties that might be in your field, any differences that you've observed in crop yield. Also, dividing blocks based on differences in your soil series, if it exists. And then it's also recommended to use the same blocks for any future sampling for consistent results. And then the second best practice is having a sample that's representative of your field. So one way to do this is to avoid sampling any field edges, as well as any wet or low spots. And then we recommend sampling in a W or a Z pattern, as you can kind of see from this image, essentially by walking in a zigzag pattern across the entire field, or in a diagonal line across your sampling area. And then it's also recommended to sample where your roots are. So for orchards, sample in your wetting zone, and for field crops, sample in the beds and not in the furrows. All right, now we will head into the field and take a look at two different methods for collecting soil samples.
My name is Yurtsi Sanchez. I'm here with my colleague Hope Zabronsky, and we're part of Cooperative Extension. And today we're going to show you how to take soil samples. So the field we're in right now is in Davis, California. It is about 108 and 130 feet wide. And they used to grow a variety of mixed vegetables here, but as you can see right now, it's in fallow and there's a lot of overgrown grasses. So let's get right into it. So you want to collect a sample that's about 8 inches deep. And so the method that I'm going to be doing today is the shovel method. And it's a little difficult, as you can see, because there's a lot of grasses. So what you want to do is first remove the top layer of any overgrowth and really expose that first layer of the profile here. And so I'm gonna create kind of a circle shape with my shovel, about 8 inches deep each time. Make sure to remove any roots or other grasses and debris, because you want pure sample. And I'm just going to put it into the bucket.
Everyone, my name is Hope Zabronsky with UCANR, and I'm out in this lovely field with my colleague Yurtsi Sanchez, and I'm going to be showing you a second method for soil sampling in the field using this soil probe that I have right here in my hand. And something important to note is that you will want to use the same method for soil sampling your entire field. So if you're using the shovel method that Yuritsi showed, you're going to want to use that method to collect all of your soil samples in your field. And the same thing is true if you're using the soil probe. So you'll want to make sure to use this single method to collect all of your samples. So the soil probe is pretty easy to use. We're going to start by removing any excess vegetation or litter. You can see we have a lot of grass right here and some grass that has become more like a mulch. So we're going to want to take that off so we have bare soil to start collecting our sample with. So you can see we've removed some of the vegetation right from the top. And now what we'll want to do is insert our soil probe, and you can see it starts to go in pretty quickly and then it gets a little bit more tricky. So what you'll do is use these handles to keep rotating it into the soil, and that's going to allow you to get deeper into the soil to collect the amount of soil at 8 inches of depth, which is what we're going for all of our samples today, using both different methods. All right, so now we are ready to pull it up. So you simply pull it all the way up. And you can see now that we have, this is roughly 8 inches that we'll need, and you're simply going to brush it off right into your bucket for your soil collection. I've collected my first soil sample. Now I'm going to move to my next location to collect the remaining 8 soil samples for this field using my soil probe.
So we've got our 9 samples that we have in this bucket, and I mixed them all up to create one big sample. And from this sample, we're going to put a smaller portion of it to send to the lab. And as you can see here, we have it labeled with the farm location, farm name, the APN number, and the grower name. And I also want to mention that if you are going to be taking samples from different plots, you are going to want to disinfect the tools that you are using just to discourage any pathogen contamination into another field.
Now that we've collected our soil samples in the field, they're ready to be sent to a lab for testing and analysis. Before collecting your soil samples from the field, you'll want to find a local lab that analyzes soil samples. The California Department of Food and Agriculture has compiled a large list of soil analysis labs across California that we will include in the chat for folks to access. For general soil fertility testing, we recommend choosing a soil lab's basic analysis. This typically includes key macro and micronutrients along with pH. You can add other nutrients to your analysis, but don't pay for extra tests unless you have a good reason to analyze additional nutrients. Basic soil tests typically cost between $30 to $60 plus mailing costs. Any additional tests will increase the cost. Make sure to contact your lab for current pricing before submitting your sample. It's also important to use the same lab every time you have your soil tested. Labs can use different methods for determining nutrient levels, which can lead to different test results. Follow the specific instructions provided by the soil testing lab you've selected. Labs typically require at least 1 cup of soil per sample. Mail the soil in a zipper-sealed bag or clean plastic bag labeled with the appropriate information required, including your field, APN, address, crops, and any other information required by the lab. In addition to the soil sample, you will also need to fill out the soil analysis request form provided by the lab company. Typically, you will find this form on the lab's website, and you'll be able to download the form to complete it. Make sure to mail the completed form back to the lab in a small box or padded envelope with the labeled soil sample and the correct payment for the analysis. We hope you found this video helpful. We will now open it up to questions from the audience.
Thank you everyone for watching our soil sampling video. If you would like to start posing some questions in the chat, we would be thrilled to answer any of the questions that you all have. So someone asked a question about the UCC lab list. At the conclusion of this workshop, Margaret and Yuritsi are going to be sharing a list of great resources, and we'll share the link in the chat, and that will have the lab list along with many other very helpful resources. So someone asked a question about why you don't want to soil sample after heavy rainfall events. Does anyone on our team who's a panelist particularly want to answer that question?
I can start to answer that question. One of the reasons is it's really tricky to do. It's hard to get a good sample, right? One of the keys is to be able to get that good representative sample, and the soil is wet and gunky. It can be really tricky to do that. So part of it is just in terms of like the ease of getting your sample. The other thing that's coming to mind is if you are looking at nitrate, nitrogen in the soil, that is readily leachable. So you could have some different results because of sampling directly after the rain. Those are my kind of two thoughts on that. I typically recommend the most important thing is that you just do it. If you're doing it periodically, just do it at the same time every year so you can start making comparisons between samples to see how things are changing if you're correcting any issues that you have.
Thanks, Annie. That's great. So another, let's see, the second question that came in, is this video available online? Yes, so after this session, we have a list of all the attendees, and we're going to hopefully upload this to a link on YouTube that we'll be able to share with folks afterwards. Just give us a little bit of time and we'll be able to share that video link, and then folks could share it kind of widely with anyone who would like access. Let's see, so Ricky asked a question about already doing leaf analysis twice a year. What value is the soil sampling going to add? Would anyone else on our team, our panelist team, like to answer that question? If they're already doing leaf analysis, what could soil analysis testing provide information for in addition?
I'm happy to answer unless Daniel or Patricia would like to. So I don't want to take all the. So the tissue testing is great for determining if your crop has adequate nutrition. So it's basically reading what is present in the crop, and then you can compare that to your critical levels and see if your crop has adequate nitrogen, phosphorus, potassium, whatever it may be. However, it's not going to tell you, for example, let's say your pH is off, and so your crop isn't able to take up phosphorus. You might see that it's low in your tissues, but you're not going to know why until you go through and test your soil. It also doesn't tell you about soil salinity, right? A lot of the important parts of soil analysis is the salinity, which affects water movement, nutrient uptake, all healthy roots, all those kinds of things. So they're really best used together because tissues can often tell you certain things soils can't tell you, and soils can tell you things that tissues can't tell you, primarily salinity and pH that can affect like what is going on in the rooting zone, particularly around water movement.
If I may add two things, that tissue testing doesn't really tell you when there is an excess of a nutrient. It tells you when there's a deficiency, but excess is not well detected by tissue testing. And the other reason why you may take soil samples is that when you take a tissue sample for some of the nutrients, it may already be too late for the current season, especially phosphorus. With a soil sample in early spring or in fall, you can make corrections before you plant your crop.
Great. So I'm going to look at a few questions that came into the Q&A part. Someone asked, in some cases, it's recommended to get a 6-inch sample and one from 6 to 24 inches. Is this useful? Well, a range in your depth is going to tell you different things about your soil fertility and your soil conditions. Typically, it's recommended to take samples between, I think, usually 6 to 12 inches, depending on kind of the different amendments that you add to your soil, sort of, if you do any tillage, how, that's being incorporated and at what depth. So it does, depend on kind of your management decisions, as well as your tillage practices. Does anyone on our team could share a reason for sampling at 24 inches of depth? That seems, a bit further than I've heard, unless, there's something happening a little bit further down within your soil. Maybe that could be longer term, testing of soil carbon or something like that.
I think it really depends on the rooting depth of the crop. When you have a deep rooting crop, especially for nitrogen, you may want to know, is there some nitrate in the second foot of the profile? When you have a shallow rooted crop, then the second foot is already beyond the rooting depth. So then it may tell you how much you have lost, but it won't tell you how much is available to the crop.
Yeah, typically if you're testing for tree crops, you might want to go deeper.
So I know there are a lot of questions coming in. We're going to take probably one more question before moving to the next section, and then we could answer any questions that weren't answered, hopefully at the end of the workshop. Any folks on the panel see a question that you would particularly want to answer? There are a bunch of questions about sort of soil depth. Let's see, sampling for biology. Let's see. Maybe we'll answer the one final question before we move to the next part of the session about sampling time and sort of when the best time to sample every year is. Typically, I have heard that sampling in the fall before adding any of your soil amendments and, any of the management decisions that you might be doing for the coming growing season generally makes sense, unless maybe you have, planting, at different times of the year. But generally you want to test before you make any management decisions and before you add any soil amendments that you could correct for any of the issues that you might be seeing. But if our panel has any other quick things to add about the time of year for testing, feel free to chime in.
I agree. Fall is a good time. Spring also, if it's possible, before you do anything in the field. The only analysis it's not very useful when you take a sample in fall and you plant your next crop in spring is soil nitrate, because with the rains it's going to change until spring. So the fall nitrate is not very useful to make plans for your next crop in spring. But the rest is totally fine in fall. And I think the most important thing is to sample every time during the same season, so that you can really follow the trend over time.
Great. Well, thank you all for the questions you asked. If you have a question we haven't yet answered, hold that question. We're going to have another question period at the end. I'm going to turn it over to Margaret now to introduce the second part of our workshop, where we'll have some presentations from our panel.
Great, thank you so much, Hope. So now we're going to get into the nitty gritty. Actually, taking the soil test is taking the soil sample is the first step. But so often I've met with growers who do that step, but then they get the analysis and they don't know what to do with it. So how do you read an analysis and then make a decision about a compost amendment, a nitrogen application, phosphorus, potassium, etc.? So our next couple of speakers are going to address that next step. When you have your soil report, your soil analysis, how can you use it? So is it Daniel next? Who's next?
Patricia.
Patricia. So Patricia Lazicki is our newest vegetable crops advisor in the Woodland office. So take it away, Patricia.
Mm-hmm. Hi. So I'm going to start us off with just some plant nutrition basics. So this is going to be review for some of you, but some of the fundamental science behind how to interpret the soil samples that we're taking. So just on a very basic level, plant nutrition is not that different from our nutrition. Of course, their carbon they get from the atmosphere through photosynthesis, but their nutrients they're taking up through the soil. And just like we need our nutrients in the right proportion, from the right source, at the right time, so do plants. So a distinction that you'll hear a lot is macro versus micronutrients. And just to be clear, this doesn't mean that macro are important and micro are not. It just refers to how much the plant takes up. So this graph on the right just gives an idea of the proportion of different mineral nutrients in a plant. Of course, it will differ by the plant and by the growth stage, but you can see nitrogen and potassium are a huge proportion of the mineral nutrients that the plant's taking up. Calcium, magnesium, phosphorus, and sulfur are the other big six, the macronutrients, and only making up a tiny proportion are the micronutrients, zinc, iron, boron, copper, and so on. And all of these, though, are needed for all plants to complete their life cycles. And these micronutrients often serve very specialized functions within the plant. So for example, boron is really important in pollen tube formation. So for a crop like almonds that really depends on good pollination for a good yield, boron is going to be extremely important, although it's only needed in a small amount. And different plants will often have particular nutrients that they're particularly susceptible to or that you really want to watch out for. But in soil sampling in general, we often talk about nitrogen, phosphorus, and potassium. And that's because just experience has shown that for most plants in most systems, these are probably going to be the most likely to become deficient. And really quickly want to unpack that idea of deficiency. This is a really useful concept in the plant nutrition world, Liebig's law of the minimum, which just says that yield potential, which in the metaphor of the bucket is the water level, is determined by whatever the most limiting factor is. So in this metaphor, the shortest stick. So that just means, supposing that the short stave was boron or was something, if that's limiting the yield, it doesn't matter how much you have of everything else that the plant needs, that one thing will be limiting. And notice that these are all kinds of conditions. So variety, light, water, not just nutrients. Though a couple things to remember with this, excess of a nutrient or imbalance between nutrients can also be limiting. Back to boron, of course, it's needed by plants, but too much can also be toxic and can limit yield as well. Or there's nutrients like phosphorus and zinc that have kind of an antagonism. So if you have a lot of phosphorus, it may not necessarily poison the plant, but it may actually give you zinc deficiency. So just, this is a useful metaphor, but remember, excess or imbalance can also be a limiting factor. Next, I want to take us through some general behavior of different nutrients in the soil. So when you think about nitrogen, I want you to remember the word dynamic. Nitrogen isn't really contained much in rocks. It mostly comes in organic matter. It's always being cycled, and this cycling is mostly done by microbes, so it'll depend a lot on the moisture, the temperature, the oxygen. It changes forms really quickly. And the major form in warm aerobic soils, so Central Valley soils in summer, is going to be nitrate. And notice the negative charge on there. This is important because the surfaces of clay particles in the soil, which makes up most of the soil surface, is also negatively charged. So these are going to repel each other. So this means that nitrate not held on the soil surfaces, it's going to be in the soil solution. So this makes it really mobile. It's drawn towards roots when they're transpiring. But it's also mobile in water on days like today. When you get a lot of rain, it's going to be leaching down. So it's easily lost below the root zone. It also has, excuse me, gaseous forms, so easily lost to the air as well. So very dynamic nutrients. So what you get on a soil test will just really be a snapshot. Phosphorus is kind of the opposite. You can remember the word sticky. It sticks to soil surfaces. It easily precipitates with other minerals, really dependent on pH. It absorbs onto clay surfaces. So this means it won't be moving a lot in the soil. It's not like nitrate where it will go to the root has to come to it. For potassium and calcium and magnesium, also you'll often hear these called the base cations because they've got a positive charge. These, I want you to remember the word exchangeable. So that positive charge means that they're held onto these negatively charged soil surfaces, but they can be exchanged off of them. For example, roots can produce hydrogen ions. In order to get them, they can exchange with a soil solution. So this means that these will be less mobile in soil than nitrogen, but more so than phosphorus. Probably leaching won't be too much of an issue. And because they're held on these clay surfaces, the more clay that you have, the more cations that soil will hold and the more strongly it will hold them. And another distinction that's important to remember is between available and total nutrients. So not every nutrient that's in the soil, of course, is available for plant uptake. They can't directly take up large organic molecules. They can't take up potassium that's part of a rock. They can't take up phosphorus that's precipitated out with calcium. But all of these nutrients are changing between forms all the time, between plant available, non-plant available forms, and at different rates. And so what this means is that most soil tests, and especially phosphorus and potassium, are more like a regionally calibrated index of availability rather than you have 2 tons per acre of available phosphorus in your soil. So Daniel's going to talk a little bit about this, but basically just they do a lot of experiments and the interpretation of a soil test is based on like when we took from this depth at this time and did this test on it, values between this and this seem to be best for this crop. So super crop and regional dependent. And then also the location matters too. Sorry. So even if the nutrients in a form that might otherwise be available, if the roots can't reach it because it's say way on the shoulder of a bed where it's very dry and the roots don't go, it's not going to be able to be available to the plant because how is it going to get to it? So this really underlines the importance of sampling in the root zone in order to use that number. And then wanted to give a brief note on organic matter, pH, and salinity, which you'll often see on a soil test, even though these aren't really nutrients, but you can think about them as the soil habitat. Like we all know organic matter, it's source of soil fertility, nitrogen, phosphorus released from it. It supports the soil biology that does the nutrient cycling, improves soil structure, water infiltration, retention, and so roots are going to be able to use the soil much better. The better structure it has, the better water properties it has. So generally with organic matter, we tend to think that more is better. But also the maximum that you can expect is defined by the soil type and also the climate. So in California, generally, depending on the soil type, we say about 1 to 3% is normal. Salinity is another important part of a soil test. This is basically the salt concentration in the soil solution. So the saltier you get, the harder the plant has to work to get the water. Depending on the salts, it can also damage the roots. It can stress microbes. That plants will have different tolerances. So some really sensitive, some much more tolerant to salt, and it will just depend on the crop. And then finally, pH, it's a really important variable for nutrient availability. So this is a classic chart on the right that you're probably available with and or probably familiar with, and just shows that most of these nutrients, both macro and micro, will tend to be more available at neutral pH. But also it's important to remember that what a good pH is really depends on the crop, because some are adapted to higher low pHs. So that was a lot of chemistry and biology and physics in a very short time. So just some take-home points to remember that plants need the right nutrients in the right amounts and a good habitat in order to be able to use them. Different crops will have different requirements, and soil test interpretations will be crop and region specific. And then also your sampling strategy will be the key to getting results that you can use. And we'll talk more about resources later, but just to emphasize the importance of getting reliable information. So I've put up this soil textbook if anybody's looking for just a good basic soil resource. This is a really good one. Western Fertilizer Handbook. And just pay attention to the source of your information and whether you can apply it to your region and to your crop. And local extension is a good resource. This is what we're paid for, is getting you this information. And so with that, I want to thank you And here's my information. Feel free to reach out to me if you have any questions. And with that, I think is Annie.
Hi, everyone. Thank you all so much for being here today. I'm glad that we have a lot of people in the audience that are soil lovers like we all are. And I'm really honored to be presenting with such a wonderful group of people. My name is Annie Burkholder, and I'm a soil scientist and certified crop advisor with Della Valle Laboratory. And as Margaret was mentioning, you can get a great composite, representative sample, send it to the best lab in the world. But if you get the results back and you don't know what to do with them, all the rest of it was kind of a waste of your time. And so I know it can feel daunting to, learn how to interpret a laboratory report. And it's also tricky because all lab reports look a little bit different. So obviously, our report for our company is going to be different, but I think that hopefully a lot of it is the same. If you are viewing a lab report from a different company, you'll probably need to speak directly to them if you have some questions, just because even for me, it can be hard to always interpret other lab reports. Yeah. All right, so just some things to consider when you're choosing what lab to send your samples to, maybe potential questions to ask a lab that you're considering working with. Really, one of the really important things is just making sure that the methods align with UC recommendations and interpretation guides. So I will go through a little bit. Some methods are really made for California soils because we have a much different climate and different types of soils than the soils on the East Coast and Midwest. And so generally speaking, I do recommend choosing a lab that is in California because they're going to understand the California conditions and what methods are more appropriate for here. Other things to consider obviously would be cost, your turnaround time, and then, I talk to your neighbors and so on about reputation. You want to go with a lab that has a good reputation. And then because you want to be able to interpret your results, you want to make sure that maybe ask the lab for an example of a report and, does it make sense to you a little bit? Obviously, it's still helpful to talk to a kind of a professional, whether it's the, cooperative extension folks or a CCA. But you want to look at the results and, it seems clear. And then you always want, as Patricia was noting, something crop specific. Every crop has different needs, different tolerances to pH, salinity, and all that. So with every, whenever you turn in the paperwork, indicate the crop and make sure it's a crop specific footer or interpretation guide that you're using. And then really, what's the service like? So once you get your results back, is there going to be somebody there who can answer questions when you have them? Because there are always questions, right? So I guess that's part of the reputation, but either, you need to have somebody that you're close with that can help you with that, or if not, the lab staff can also help potentially. I just want one little kind of note, just be wary of computer generated calculations. Even our lab, we do some of these, but you kind of take them with a grain of salt because as you all know, the particular site-specific factors vary significantly, and those really make a big difference in terms of what the recommendations may be. So just sort of use your critical thinking hat when you're reviewing computer-generated calculations on lab reports. So this is just an example of how our lab report looks. Again, this is how ours looked. Every lab you look at will look slightly different. We do have multiple fields on one page. I was speaking about methods. All labs should, when you get your results, have very clearly defined methods. So in our case, the methods are along that top row. and it's from the soil, plant, water. I can't read it because there's a Zoom bar above it, but the methods for the Western region. So if you're looking at what methods the lab offers, every lab should have that on their report. So it's also helpful to look at the units. So in this case, the units for our salinity is milliequivalents per liter. And what that's telling you is that this lab analysis is actually, because of the liter, you know that's a volume. So this is actually done on water. So this is actually a water extract. The water and the soils that equilibrate, and then you suction off the water and you actually run the method on that. And the idea behind that is that that's really the soil solution that the plant is experiencing. And this is called the saturated paste extract. And this is the best method for determining salinity in California. Again, something I would look for if I were choosing what lab to send a sample to would be, do they do the saturated paste extract? Because it's going to be more accurate in terms of salinity and actually boron as well. So anything with the liter at the end, you know, is done on water. And then if it says per kilogram, then that's going to be an analysis that's done on your soil. So this is actually like an extract to pull the water out of the soil. So that's per weight. And then, as I mentioned, and Patricia, every crop has different requirements and sensitivities and tolerances. So it's important to indicate what crop you're planting. Most of the time, as far as I know, you can indicate as many crops as you want. So like say because I know small farmers have a very diversified system. So you could have 5 different crops, and we would just do 5 different pages with 5 different footers. And then the colorization would change too. For example, a boron of 1.4 may be very problematic for a citrus tree, but for a tomato, you'd be fine. So it's important to definitely have the right footer. So I'm just going to briefly kind of just go over the layout on the report. So the first is the saturated paste extract, and this is basically a percentage. This is how much water your soil can hold. So it is an indication of soil texture. So the lower the number, the more sand you have, the higher the number, the more clay you have. Organic matter also holds a ton of water. So if you have a very high organic matter soil, that's going to increase your SP. The areas that happens are very specific, like the Delta, typically in the Central Valley. You know, even when you're doing a great job trying to grow your organic matter pool, it's still hard to get it too high. And then your pH. So Patricia did a great job describing like that nutrient availability based on pH. So obviously nutrients can either become are not easily taken up at certain pHs, or they can even become really toxic, especially at low pHs. You get some heavy metal toxicity. So most crops just want a kind of neutral pH. There are exceptions, but you know, 6.5, 7.5, you're generally going to have happy plants. So our total salinity. So this is the total indication for total salts in your soil, primarily your calcium, magnesium, or sodium, but it needs to be used in conjunction with understanding the relative proportion of calcium, magnesium, and sodium. So typically calcium is our happy salt, magnesium can be, I have the pluses or minuses, magnesium can be good or bad, and sodium is generally bad. So typically you want calcium to be your dominant cation, and you can get that using gypsum, or compost has a lot of calcium in it as well. So ESP is another important parameter to look at. It's a calculation based on your calcium, magnesium, and sodium, and it's basically looking at how dominant is sodium in the system. And with soil, we are looking at nutrition, but on this page, this is all like salinity. And again, the ESP that has a huge effect on soil structure. Same with EC. At very low ECs, you get poor water infiltration. At very high ECs, especially when dominated by sodium, you can get very poor water infiltration. If you have really high sodium soils, your plant has to work a lot harder to take up its water. So it's going to stress the plant out more. So these aren't really so much nutritional, although, you know, some of these are plant essential nutrients. It's really more about the soil system and your water infiltration and soil structure. And then boron is also an essential plant nutrient, and in many cases, boron fertilization is required. But it can also be toxic, and that's sort of a region dependent. So here in Yolo County, it's a big problem. In other areas, boron is very low. And this has a lot to do with just even the irrigation water. We tend to have high boron in our irrigation water. And then we get into, so all of that really wasn't nutritional, right? Like most of that was just about the soil structure. But obviously we're also looking at nutrients. So I'm just going to go over NPK really quick. And so nitrate N, that's your plant available form, right? That's readily taken up by plants. You can test your soil just after planting, just before planting, and get a snapshot of the nitrogen concentration in your soil. There is an expiration date on that sample because nitrogen does readily leach through the root zone. So for example, if you're putting on some irrigation water at planting, that could leach some nitrogen through your soil. So you do have to take it fairly close. You wouldn't take this in the fall. You'd really want to take it very close to planting. And that nitrogen present in the soil can contribute to your crop's overall nitrogen budget for the season. The rule of thumb is 1 milligram per kilogram equals about 3.5 to 4 pounds of nitrogen. And Daniel will speak about this as well. But you can see, I mean, in that crazy situation where there's 104 milligrams per kilogram, there's a lot you can learn from that. One is, what the heck was going on last year, right? As a report card, you're thinking, clearly we applied way too much nitrogen to our system, or we had crop failure and none of the nitrogen that we applied got taken up by the crop. So either way, it's not a good situation to be in. But anyways, that's almost 350 to 400 pounds of nitrogen, right? So that technically could probably your most crops don't need much more than that. So, but again, you're looking at some different ways. One, you're looking at what do I have available for this year, but you're also looking at what does this tell me about what I did last year? In the question of testing multiple depths where I have 0 to 1 and 1 to 2, you can start seeing, are you leaching nitrogen? So if you have a lot more nitrogen in the second foot than the first foot, it indicates that you're leaching nitrogen. You're probably need to look at your irrigation management, your timing, all that stuff in order to reduce your nitrogen leaching, because once it's past that root zone, it is gone. You just threw your money away, and now we're actually potentially polluting the groundwater. So it's just important to learn as much as we can from these results. Soil nitrogen will always, some of it will be lost. 100% of that would never be available to the plant. So it's just important. There's an efficiency factor when you're thinking about how much nitrogen will be available to the plant. Excuse me. So phosphorus and potassium fertilization is needed in pretty much all row crops to some extent. And the amount that you need is dependent on the specific crop requirement. So crops have a very differing rates of phosphorus and potassium they might need. And then also what is your starting test level. As Patricia said, these aren't going to really move through your soil as much. You can kind of technically load up on these fertilizers because they're not going to become unavailable. They're not going to move through your soil and be lost. I think it's also important to kind of understand this idea of a maintenance application versus a corrective application. So a corrective application would be, I have extremely low levels and I need to bring them up. And then you're going to be adding like a lot of that particular nutrient. Whereas a maintenance application is typically based off of a removal rate that is typically published. And so you can basically add in whatever your crop took off. And that would be for if you have an adequate amount of that particular nutrient. There are two methods that are common for phosphorus. That's another thing to look at when you're choosing your lab. So the Olsen phosphorus is better for higher pH soils, and the Bray is better for lower pH soils. So in our lab, we run pH, and then we, if we have lower pH, typically California tends to have the higher pH soils, but there are instances where it's low. And so we'll run the Bray on an as needed basis. Couple of other notes, phosphorus availability decreases in cool and wet soils. So if you're growing an early season crop, you might need more phosphorus. And when phosphorus are low, banded applications may be more affected. Potassium is really needed at huge amounts in a lot of crops. I work with a lot of tomato growers, and I recommend quite a bit of potassium. They actually need as much or more potassium than nitrogen, and it's can often be overlooked. So really important to look at that. Again, I really believe in tissue testing to check all of these things, right? Because that's going to show you what the plant is actually experiencing. So I'm a big proponent of tissues. It works in conjunction with soils. Yes, again, and even when your potassium levels are adequate, you may need, you probably will need additional potassium just to account for what's removed by the crop every year. So anyways, I know I could talk for hours about this, so I tried to put it in a short presentation. I hope that that was helpful, and always feel free to contact me if you have any questions or more detailed questions. I didn't get to everything I wanted to. So yeah, please feel free to reach out if you have any questions at all going forward.
Okay, well, great. In my presentation, I'm Daniel Geisler. I'm a nutrient management specialist at UC Davis. And in my presentation, I would like to discuss how to turn lab results into a fertilization program. And let's start with phosphorus and potassium. And as Annie has mentioned, the results from a lab may look different depending on the lab, but most of the time the availability is on a scale from very low to very high. And the goal is to have some intermediate or adequate or normal availability of the nutrients. If the availability is low, that means the crop is likely going to respond to fertilizer applications. And if the level is low, you may add a corrective application, which means you may add more, you may want to add a bit more fertilizer in form of potassium or phosphorus than the crops actually need, so that over time you will reach the intermediate or appropriate range. If the level of phosphorus and potassium is high, that means it's very unlikely that the crop will respond to a fertilizer application of these nutrients. So in these cases, you may reduce the application rate or even skip it for a year or two. If it's in the adequate range, that means it's not quite clear whether or sometimes the crop may or the crop may not respond to a fertilizer application. Still, if it's adequate, as Annie has mentioned, it may be worth to add at least the amount of nutrients the crops will remove from the field at harvest, which would be the maintenance application. So that way you will keep the level over the years in the same range. So you will have an adequate supply of nutrients. To better understand how these recommendations were developed, I would like to show you how people actually determine what is low, high, and what is adequate. And here's an example for Olsen P for available phosphorus in cotton. And what the scientists did here, they selected some 30 or 40 fields. Each dot here is a field. And at the beginning of the season, they measured Olsen P, or phosphorus availability, which is here on the horizontal axis. In each field, then they had an area where they applied fertilizer, phosphorus fertilizer, and an area where they did not apply fertilizer. And they calculated how much did the yield, the cotton yield, increase when fertilizer was applied. And what they found is that if phosphorus is very low, below 5 ppm in the soil, then it was very likely that the crops will respond to a fertilizer application. On the other hand, when Olsen P was higher than 10, a response was very unlikely. And so that below 5 would be considered low, above 8 would be considered high, and the adequate range is somewhere between 5 and 8, where you can see some fields had a positive response, other fields did not respond. So that's how these recommendations were developed. And these trials were done for the different nutrients and for different crops. And as Annie and Patricia already mentioned, that's why we consider these tests for phosphorus and potassium as indices of availability, and not, it would be incorrect to convert them into pounds per acre and say, oh, okay, it's more than the crop will need, so I don't have to fertilize. It's really, it's correlated to the response of the crop. So now, where can you find information on how much to add and what these, what low and high values are? For a few years, we have developed and maintained the California fertilization guidelines, where we summarized the literature, the available literature, mainly from California, and complemented it from literature from other parts of the United States or the world with similar conditions, and put them online in the California fertilization guidelines. So far, we have developed guidelines for about 30 crops, including annual crops and some tree crops. So when you go to these guidelines, let's say you click on cotton, you will find information on nitrogen, phosphorus, and potassium. For some of the crops, a micronutrient may also be included if it's important for that crop. And you can find information on soil testing, plant tissue testing, and fertilizer applications. So for example, when you go to phosphorus and soil test, you get a brief summary of how to take soil samples and how to turn a lab result into a fertilization application rate. And when you make the table a bit bigger, you can see that's for Olsen P, for phosphorus. As we have seen in our graph before, an intermediate range would be somewhere between 5 and 8, which means that the phosphorus application is more or less how much the crops will remove in that season. If it's low, below 5, then the recommendation is to apply a bit more, so a corrective application, so that over the years we will reach the intermediate level. And when it's high, it's really, when it's above 8, it's not necessary to apply phosphorus, but keep testing. At one point it will reach the intermediate level, and then you would need to start applying fertilizer again. So you can find this information for quite a few crops online, and the document Margaret is going to share with you with the resources. The link for the guidelines is also on that document. It's a website, but it works on your smartphone as well, and the link will be in the document Margaret is going to share with you at the end. Now, when you know how much to apply, the question is, when should you apply the fertilizers? And as Patricia has mentioned, phosphorus and potassium are not leached in the soil. There may be an exception for potassium in a very sandy soil with a very low cation exchange capacity, but normally they are not leached. So they can be applied before the growing season or even in fall, whenever works for you. Potassium can be applied through the drip system during the growing season, if you like. Fertigation with phosphorus is a bit risky. If there is calcium in the irrigation water, it may react with calcium, precipitate, and clog the emitters. So need to be, if you drip irrigate, you need to be a bit careful with phosphorus. Now, nitrogen is a different story. As Patricia and Annie have mentioned, it's easily leached. So it needs to be supplied during the growing season. If you apply all of the nitrogen pre-plant and then you do a heavy pre-plant irrigation afterwards, the nitrate may actually already be leached below the root zone and no longer available for the crop. So nitrogen is best split during the growing season in smaller applications when the crops actually need it. So the question is, of course, when do the crops need nitrogen or nutrients in general? And for many crops, the uptake curve is S-shaped. So here we have on the horizontal axis, we have time from seeding or transplanting to harvest. And the y-axis is just crop nitrogen uptake in % of the total. And normally after seeding for the first month or so, crops need very little nutrients because even though they start growing very quickly, but the biomass is still relatively low and the nutrient uptake is not so high. But after the first month and during vegetative growth, that's the period when crops need most nutrients. So that's the period when you really need to supply nutrients to the crops. After flowering, when you grow something for seeds, let's say sunflowers or small grains or corn, after flowering, nitrogen uptake often slows down. So then it's not, a lot of nitrogen does not need to be applied or be available after flowering. There are a few exceptions to that rule. For example, lettuce or broccoli, they take up nitrogen or nutrients until the end of the season. And the reason is, of course, they are harvested before flowering. So they are still in the vegetative growth phase when they are harvested. So we hardly see a slowdown in uptake. A similar situation is with strawberries. The varieties we have in California, they produce for a long period of time. So they need nutrients throughout the growing season. And another example would be melons, because melons are indeterminate. They continue producing vines and leaves, even though they already have melons that are ripening. So vegetative growth doesn't really stop for melons when the fruits are ripening. And uptake curves you can also find online. And again, that will be in the document Margaret is sharing with you at the end. So for nitrogen, if you want to know what's the nitrogen availability, you normally measure nitrate in the soil, because nitrate nitrogen is the form that's directly available. And here it's actually possible, unlike phosphorus and potassium, you can actually convert your lab result into pounds per acre. And as Annie has mentioned, 1 ppm corresponds roughly to 3.5 to 4 pounds per acre. It's not an exact number because it depends on the bulk density. So for example, this ratio would be lower in high organic matter soils. When you produce in the delta, you have 5 or 10% organic matter, then the bulk density is lower. So this ratio would also be around 3 or even lower. And also already mentioned before, in drip irrigated fields, the volume the roots colonize may be smaller. So then that would also justify using a lower conversion factor. And again, very important, if you take a soil nitrate test and afterwards you have a heavy irrigation or heavy rainfall, that nitrate may no longer be in the zone where you measured it. Now, the guidelines, or we have guidelines for 30 crops, but in California there are many crops grown. and probably on small farms, you may grow some crops where it's really hard to find any information. So what do you do in that case? And phosphorus, potassium, you may find recommendations for a similar crop, and you will see they're not that different from one crop to another. With nitrogen, it's a bit more challenging. So here's one suggestion what you can do when you really don't have any information on how to manage nitrogen in your crop. As we have seen, is the highest uptake is during vegetative growth. When we look at the data, crops hardly ever take up more than 5 to 6 pounds of nitrogen per acre per day during the period of highest crop nitrogen uptake. So you can take a soil sample during the season before you think you need to apply some fertilizer. And based on the conversion of 3.5 to 4, if you have a soil test nitrate N value of 20 ppm, that would mean there are some 70 to 80 pounds of available nitrogen in the soil. Now, when you compare that to 5 to 6 pounds of uptake, maximum uptake per day, you can see if you have 20 ppm of nitrate N in the soil, in the root zone, that will last at least for 10, probably 14 days. So if you take a soil test and it comes back at 20 ppm or higher, you don't have to fertilize yet, but come back in a week and take another sample to see whether it has changed. If it's below 20 ppm, you may apply some nitrogen, just enough to raise the level again to 20 ppm. So if it's 10 ppm, you may want to apply half of what is half of that, 35 to 40 pounds. Then you know, okay, that lasts again for another 10 to 14 days. And at the end of the season, you should reduce the threshold, because if you don't want to leave 70 to 80 pounds of nitrogen back in the field when you harvest the crop. But so that's a method to use soil tests and determine whether you have to fertilize. And when you produce a new crop or in a new field, it's a bit time consuming, but soon after a year or two, you will have experience and you can take much fewer samples because you kind of know how the crop reacts, and you may only have to take a few samples during the season, or even rely on a leaf sample to see whether your fertilization management is appropriate or not. Okay, that's what I have prepared for my presentation. Thank you.
Great. Well, thank you, everybody. I'll stop sharing real fast. So I'm going to close things out with a little bit of a review and an introduction to the resources. So it was such an amazing set of presentations. First, getting the samples done correctly, then orienting yourself to the soil test, the analysis. What does it tell you about soil function? And then what is it telling you about the abundance of different macro and micronutrients? And then pairing that with the planned use for the soil. So what are you growing? What does that crop need? And when does it need it? So the last little piece to that is getting the information you need to accompany you during those steps. Often it's easier said than done. And it's a sort of a long-term investment, learning how to do all of this and put it all together. But thankfully, there are some really amazing resources to really guide you through this process. And I think it would be safe to say that all of us here regularly consult these resources to get the numbers, to review the numbers. This is not something we all hold in our heads, although some of you do hold much of this in your heads. But we frequently, are consulting these resources to get those numbers. So I'm going to introduce you to some of our favorites. And so this first one I'm going to share is actually going to help with that first step of conversions. So this can be some of the biggest barrier. One of the biggest barriers to actually using it is, how do I convert things from ppm or whatever the unit is on your soil test to pounds per acre? The recommendations that Daniel just mentioned are given in pounds per acre typically. Although sometimes, the nitrate test strips will be giving you the ppms. And then also for small scale growers, it can be really hard to convert acres to a bed system. And so I'd like to first bring your attention to this conversion tool. And Patricia was instrumental in developing this, but really this is a summary of how to access some of these quick conversions. So some of my favorites that are hard to find are, as mentioned, not all soil tests report the same thing. So sometimes some soil tests are nitrate, NO3, which is the total compound, versus nitrate N. So looking closely at your numbers, if your number is really high or low, sometimes you want to double check what exactly it's reporting. And so we provide those conversions here. Another one I want to point out is how to convert from your beds to acreage. And so you can put your numbers in here and do that calculation. And then the last part I want to do is these volumetric and weight conversions. It can be so hard when things like compost are given to you in, the recommendation says apply 5 tons to the acre. And you're like, but I order compost in yards, or I use wheelbarrows and buckets for compost. How do I do that conversion? So here are some handy numbers to help you through that. So that's the first one I want to share with you. And then I will repost the link. And I'm going to now go through some of the resources in the document. So this is a Google Doc that I hope you can all click on the links. So now I will share my screen here. Okay, so this first one here is the Western Fertilizer Handbook. It's an actual book. Patricia had mentioned it earlier, and myself working with soil scientists, some of them here, they're always saying, oh, that's referenced on page blah, blah, blah. You can find it. So I know that this is like the #1 handbook used by so many soil scientists and folks who are doing the labs and giving the guidance. So if you'd like to have a hard copy, this would be a book to have in your library. Others are listed there. If you want to review the protocols, there's a couple of great links. I'm going to take you to this one, which is the soil nitrate quick test. So this is put together by the Agronomy Research and Information Center, and they just have all these great little videos and tools specifically on this quick strip tests. So you can come here and get more guidance on that. And sampling for orchards. We didn't talk too much specifically about orchards, but there's some guidelines there for orchards. Here now, soil testing labs. Here's the link to the labs. And you have to go through a couple of steps to get to the link. But basically, you'll get a list of labs. And sometimes it's just nice to find one that you can drive to and drop off a soil sample. So that, is often a good reason to pick a lab. Okay, and then the interpretation guidelines. So I have a lot of materials listed here, and you can get into some of the nitty-gritty, and throughout your soil sampling career, you may come across different questions, so you can reference that here. This conversion tool with the asterisk is the one I was showing you when I first started talking. And unfortunately, you have to go to that zip drive. It's actually a document that's associated with our estimated nitrogen availability document, the 8712. So just keep clicking and you'll get to it. And then if you aren't familiar with the system of translating linear bed feet to acreage, this is one of my favorite articles on how to do that. So the recommendation says apply 500 pounds of this fertilizer. How do you get that onto, a 3-foot wide bed that's 20 feet long? So this document, this article will guide you through that. And then some of those links that Daniel talked about, or is it up here? Sorry, the California Fertilization Guidelines. These are those guidelines that Daniel walked us through. So you can find all these different crops and some tree crops and get the sort of full profile about different nutrients and looking at the fertility guidelines based on the time of sampling. And that's just about it. I have a couple more links open. This is a tool that also comes from the Geisler Lab on mineralization of organic amendments. So you can look at the release of different fertilizers or composts that are providing nitrogen to your crop. So that's all I have to share. And I will pass the mic over to Hope.
Thanks, everyone. And thank you to our panelists for really engaging and informative presentations to hopefully give folks a really, comprehensive understanding of how do you start with this process all the way through, as Margaret mentioned, how do you actually interpret the results and how do you translate them into management decisions on the ground? So we have a couple minutes if folks would like to stick around to ask a couple questions while we have this really excellent group of panelists. So you can either ask your questions in the chat or post them to the Q&A and we will answer them as they come in. But thanks again for joining and feel free to pose any kind of remaining questions that you have. And I did want to mention, so after this workshop, we will share all of the resources that we went over today with the participant list. So even if folks had to jump off early or weren't able to access all the links, we'll send those post Zoom to everybody who joined for today. Someone asked a question about if there's anything they should consider in particular when using recycled water. And I'm assuming they mean in terms of sort of nutrient concentrations or anything like that.
So it would be in a lot of ways the same as using any irrigation source. So you'd want to test it. Recycled water can have a lot of like salinity issues would be probably the number one thing that you'd want to look at. So I would definitely test your water and see what's in it to even see if it's appropriate to use. And then if it is appropriate, are there any other management practices you need in order to lessen any potential problems associated with using that water. And then I'd say, depending on what the system is, you may, in your water test, you may not want to run a typical water test. There may be other constituents you want to look for, like, I don't know, depending on what that water did, like there may be other things you want to look for. So I would think about that to make sure you're getting a very full suite of potential problems. But I know, recycled water is a great opportunity to reuse and is used in a number of situations successfully, but definitely do your homework.
And there was another question in the chat, maybe you know the answer to this, Annie, about if, for any soil samples in particular,
if you can possibly store them before sending them to a lab. I know it's a best practice to sort of send them in immediately, but does it depend on, the type of soil? What's kind of the maximum amount of time that you could wait before maybe sending a sample to a lab?
So the biggest things of concern would be if you're doing any like pathogen testing, you obviously have to get that in right away, keep it cold. Even nematode testing, you'd want to make sure that that's kept cool-ish and shipped to the lab immediately. I'm not too concerned about your typical nutrients. I guess your nitrate could do something potentially, but if it's kept fairly cool, I don't really, it's not too much of a problem. So I wouldn't worry, I would get it there within a reasonable time frame. But it's not like you have to rush to get it in. I don't think much will change.
And then someone asked a question, to do the saturated test analysis, would it improve the results for your crop if you provide the lab with your own irrigation water?
Does anybody else want to take this one? Okay.
I don't think so. I don't think it would help to do the saturated paste extract with different water because it's standardized for DI water. But it would definitely make sense to send in an irrigation water sample and have it analyzed so that or it will help you if you see you have high sodium or something is high, whether it is from the irrigation water or whether it's already in the soil. So I think sending in an irrigation water sample makes sense to have it analyzed, but I don't think it would help you if the lab would use your irrigation water for the saturated paste extract.
And then someone asked a question, let's see, the question says, someone mentioned calcium in the water, parentheses, fertigation could be problematic when applying P. Do you also recommend water sampling prior?
Yes, definitely. So phosphorus and calcium, they can react, especially if the pH is neutral or high, and form calcium phosphate, and that would precipitate and could clog your emitters. So if you want to apply phosphorus through the irrigation system, you should analyze your irrigation water. And another solution, and in addition to that, if there is some calcium, you may want to acidify the irrigation water, so to prevent the buildup of calcium phosphate. But so it is a bit tricky. And the other thing to mention is that phosphorus is a nutrient that helps seedlings grow a good root system. So phosphorus, and that's one reason why phosphorus is often applied pre-plant, so that it is in the soil for the seedlings to produce good roots. So there is often, it's often better to apply it pre-plant than in season. But if you want to apply it through the irrigation system, be careful, know what's in your irrigation water, and adjust the pH if necessary.
Great. And then really quickly, maybe our last question. Someone said that their tests indicate they have high nutrient levels, but they also have high pH, especially later in the season, as their groundwater also has high pH. How can I tell how much nutrients are actually available with higher pH?
So you will see the reduction in nutrient availability in the soil test. Like if you test the soil, you'll actually get a lower value. But I would look at your tissues in that case, right? So the tissues are actually going to tell you what is the status of the plant. So, potentially testing your tissues at different times of the year will let you know. But like I've worked with really acidic soil, and you're going to see these crazy manganese levels because manganese becomes very available at low pHs. So you do see that reflected in the soil test when you have extreme pH values. But again, the end of the day, it matters what's in your tissue. That's like what's growing the crop and giving you your yield. And then just, I'd say one about water sampling. Water sampling is so important. Whatever's in your water ends up in your soil. So if you want a quick look at like what's going to happen, just look at your water, and that gives you so much information. So just a real plug for water sampling. I just had to.
Thanks, Annie. All right, folks. Well, I think with that, unless there's anything else from our panelists, I think we're going to go ahead and wrap up the session. And we really appreciate everybody joining on a Monday evening. And hopefully this session was informative, and we'll follow up post-session with some links and some resources. And I hope everyone has a wonderful week. Thanks again.
Big virtual applause for all of our wonderful panelists here. Thank you all so much for coming out, and we hope to see you at day 3 of the conference. We'll see you soon.
Thanks, everyone. Thanks, Evan.
Thank you.